Hello students, welcome to my class. In my last lecture, I was discussing about the theory related to p block element. Today, we will discuss few questions related to this topic, and definitely it will help you a lot during your board exam preparation. So, let us start the topic, that is the question answer round. Now, read the first question. What is given here? That is, ammonia is good complexing agent. That is, it able to form complexes. Why? Listen. As we know, in ammonia there is a lone pair of electron. If it has a lone pair of electron, it will act as a Lewis base. That is, it has a donation tendency of lone pair of electrons. Yes. Now, when the transition metal which act as a Lewis acid during complex formation combine with NH3, they form complexes like FeNH3 whole 6 K4. This is a complex, and this is the complexing agent. This is, that is, it act as a Lewis base because the central metal atom act as a Lewis acid. Why central metal atom act as a Lewis acid? Because they have partially filled D subshell, and they can easily gain the electron pair from the ligands. What is ligand? That is, my friend, this one is Lewis base. So, we can say due to the presence of lone pair of electron, it is good complexing agent and it helps to the formation of complex compounds. Clear, my friend? Now, I am going to wrap this part and we will discuss the next question. The next question, what is the next question? Listen carefully. Look at the next question. Listen carefully. Again, NCl3 is an endothermic compound. What I am telling, NCl3 is an endothermic compound and NF3 is exothermic compound. That what does mean? That is, this one is endothermic and this one is, my friend, exothermic. Clear? What will happen? NCl3, we require N2 plus Cl2, yes, and NF3, that is, there is N2 plus F2. Clear? The energy released during the formation of NF3 is more than the energy required to break the nitrogen molecule into atomic form, into nitrogen atom, and fluorine, to break the fluorine molecule into fluorine atom. Why? Because fluorine has a small size. And it has low dissociation energy. Remember this. If it has low dissociation energy, then it can easily be converted to fluorine atom. That is, the bond can easily be break. If bond easily be can be broken easily, then we require less amount of energy. So, during the NF3, during the formation of an NF3, the energy released is more than the energy required for breaking the nitrogen molecule and fluorine molecule into nitrogen atom and fluorine atom. Due to this reason, it is the exothermic compound. Yes, sir, definitely you are correct. Now, what I am telling, as we know, chlorine is larger in size than fluorine and it has high bond dissociation energy in comparison to fluorine. Clear to you? So, the energy, in this case, the energy released is more than the energy required to break the nitrogen molecule and chlorine molecule into atomic form. So it is, my friend, endothermic compound. Clear? Low dissociation, bond dissociation, high bond dissociation energy. So this one is endothermic, this one is exothermic. And the bond, this one is stable, the bond dissociation energy of NF3 is more than the bond dissociation of NCl3. Clear, my friend? This is the explanation. Now I am going to rub this part and we will discuss the next question. Listen what I am telling. Now let us move to the question number 3. What is question number 3? Explain why both, this is a good question, explain why both nitrogen and bismuth do not form pentahalide. What does it mean, my friend? It means that is NCl5 does not exist. Similarly, BiCl5 does not exist. As we know, NCl5 does not exist because, as I discussed earlier, nitrogen does not have vacant d orbital. Yes, vacant d orbital. Due to this reason, it cannot extend its covalency beyond 4. Due to this reason, NCl5 does not exist. Clear indication. But why BCl5? It contains that vacant d subcell. Still BCl5 does not exist. Yes, because as we know in group 15 element, when we move down the group, the stability of +5 oxidation state decreases and the stability of +3 oxidation state increases. That is, it is the inertness of 6s electron to participate in the bond formation take place. Though it has 6d empty 6d subcell, still to excite the s electron, the excitation energy in this case, my friend, due to inert pair effect, the excitation energy is more for moving s electron to d electron. Due to this reason, my friend, that is BiCl5 not exist. That is, it cannot be done like this. 1, 2, 3, 1, 2, 3, 4 and 5. This is 6x, this is 6p and this is 6t. The excitation energy is more, that is 2 electron. General condition, it has 2 electron. Now 1, 1, 1, 1, 1, 1. So the excitation energy to move the s electron to d subcell is more. Due to this reason, what will happen? This condition is not possible. That is, BiCl5 does not exist, but BiCl3 exists. Clear? And this is only due to inert pair effect. Am I right? Yes, sir. Now next one. NS3 has a high proton affinity than PS3. Okay. As we know, nitrogen, both NS3 and PS3 act as a Lewis base. Yes. Because they contain electron pair, that is lone pair of electron. Due to the presence of lone pair of electron, they act as a Lewis base. Yes, but due to the small size, the electron density around the nitrogen is more than the phosphorus. So it is a strong Lewis base in comparison to, it will act as a strong Lewis base in comparison to pH3, my friend. Comparison parameter matters. So, and due to the small size, the NH bond is stronger. Yes, stronger than the pH bond. So it has the ability to attract proton and convert it into NH4 plus, my friend. Because electron density more, so proton will attracted towards the NH3 easily and converted into NH4 ammonium ion. In case of PS3, the electron, there is a lone pair of electron, but in comparison to nitrogen, it has less proton affinity and it hardly form pH4 plus ion. Clear, my friend? This is the explanation related to this. As I told you, this is a completely conceptual question and you have to solve the question by applying your brain. Now I am going to rub this part. Wait for a moment, my friend. Now the next one is question number 4. Now look at the stability of +5 oxidation state decreases down the group 15 of the periodic table. This is a simple question I have discussed earlier in question number 3. What is given? The stability of the +5 oxidation state decreases down the group. As I know, if I talk about nitrogen, phosphorus, arsenic, antimony and bismuth, both has electronic configuration NS2 and P3. Yes sir, definitely. When we move down the group, what will happen? The stability of +5 oxidation state decreases and the stability of +3 oxidation state increases. Am I right? Yes sir, you are absolutely right. What is the reason behind it? That is the main thing is, my friend, inert pair effect. What I am telling, inert pair effect. Due to inert pair effect. What is inert pair effect? That is, when we move down the group, the s electron hardly participate in the bond formation. The reluctance of s electron to participate in the bond formation increases down the group. Only now P 3 electron of P participate in the bond formation. That is, they generally forms like BiF3 possible, but BiF5 hardly possible, or you can say not possible. But in case of phosphorus, PCl5 possible, my friend. This is the case. Clear? Yes sir, definitely you are correct. This is the case. Now I am going to rub this part and we will discuss the next one, my friend. Wait for a moment. Now the next question is that is 2. What? So answer. What is given in the structure of HNO3? What is the structure of HNO3? First we have to draw the structure of HNO3. This one is OH, this one is O, and this one is minus, O minus. This is the case. That is, as we know, HNO3 break like this, my friend. That is H plus and NO3 minus. Clear to you? Now what we observe here, it has a resonating structure, one more resonating structure like N. That is, now here is double bond. So what we observe that NO bond, the molecule NO bond is shorter than NOH bond. As we know, if I talk about NOH bond, this is purely single bond. Clear? But if I talk about the NO bond, here what we observe, they have two resonating structure. That is, in both the NO there is a movement of double bond. That is, it has partial single bond and partial double bond character. And we know single bond is more bond length, single bond length is more than the double or partial double bond length. Due to this reason, NO bond is shorter than NOH bond. NOH bond is longer. Now the thing is it a correct resonating structure? One more thing I am going to tell lots of time during my lecture, that is, there is NO3. If anyone asks you to draw the structure of NO3, the structure is like this, my friend. Listen. As we know, nitrogen has 5 electron, 1, 2, 3. Now what we have, O and suppose this one is NO, O and H. Pardon, this is the case, N. Clear? Now put here O, H, and here is O and here is O. Listen what I am telling, that is the case here. Now wait for a moment. That is 2, 4 and 6, and here is, my friend, 2, 2, 4 and 1, 5. Now this hydrogen one, this hydrogen require 1 electron, it take 1 electron. This oxygen require 1 electron from here and 1 electron from here, and this one is 2, 2, 4 and 2, 6. So it always take 2 electron. So nitrogen here take 2 electron from here and 1 electron from here. So the bond is N double bond O that is OH. Clear to you? That is 2 and 2. Now what about this oxygen? As we know, this oxygen, my friend, it contain the still lone pair, so it will donate its lone pair, and here is a formation of coordinate bond take place, my friend. This is the actual true thing. This is not a single line. This is the thing, and the resonating structure in this case is N. Now here comes double bond, and here come coordinate bond, and here is OH, my friend. Am I right? Yes sir, you are absolutely right. That is 2 2 4, 2 2 4 and 2 6, and here now what is the resonance hybrid? We find here N O O, then OH, that is the movement of this one take place. And that means to say there is a partial double bond character. Due to this reason, it has lesser side. So my friend, I am giving you few seconds to note it down and analyze the question. Clear? So friend, let's move to the next question. What is the next question here? Wait for a moment. That is the question number 5. Now read the question carefully, what is given here. Clear? The question number 1 is, why is nitrous acid oxidant as well as reductant? Clear? What is nitrous acid, my friend? That is HNO2. Okay. In nitrous acid, what we find here, that nitrogen is in +3 oxidation state. Now it can increase in oxidation state up to +5 or +4. Now it can decrease its oxidation state to -1, 0, so on, -2, -3. Now HNO2 has both tendency, either it can increase or it can decrease, because this is the not the maximum oxidation or minimum oxidation of nitrogen. If it increase the oxidation state up to +5, then it will act as a reducing agent, my friend. Yes sir, definitely. But if it decrease its oxidation state, then it will behave like as oxidizing agent, my friend. This is the case, reducing agent and oxidizing agent. But if I talk about the case of HNO3, whether the possibility is same? Now look at, as we know in HNO3, nitrogen is in +5 oxidation state. Am I right? Yes. Now this is the maximum oxidation state of nitrogen. So HNO3 cannot further increase its oxidation state. So it will not behave as reducing agent, my friend. Again I am repeating, it will not behave as reducing agent, but it can decrease its oxidation state to +3, -1, -2, -3. So it always act as a oxidizing agent, and I have discussed this thing. Concentrated HNO3 act as a oxidizing, strong oxidizing agent. Now this is explanation. Am I right? Yes sir, you are absolutely right. Now I am going to rub and we will discuss the next question, the second part of this question. Second part, what is the second question? That is the question number 2 here. PCl5 is ionic in nature in solid state. As we know, PCl5 in solid state, PCl5 in solid state exists in two forms, PCl4 plus and PCl6 minus. That is tetrahedral cation and octahedral anion, my friend. Again I am repeating, tetrahedral cation and octahedral anion. So we can say PCl5 in solid state act as a ion, that is ionic in nature. Clear, my friend? Yes sir, completely. Now I am going to rub this part and will discuss the next question. Now what is the next question? Read the question carefully. The question number 6. 3 marks question, that is question number 6. What is given here? That is 1, this is the answer. Now, H3PO3 is diprotic acid. What does mean by diprotic, my friend? Diprotic, that is basicity. Basicity is equal to 2. If I write here draw the structure of H3PO3, OH and H, H3PO3. What we observe here, that is 2 hydrogen is directly linked to the oxygen, and this 2 hydrogen, that is high polarity, and it easily release. So, due to the releasing, that is the polar here hydrogen which is directly linked to oxygen, it can easily release this 2 hydrogen, that is it has basicity 2. If it has basicity 2, then it is, my friend, diprotic acid. Again I am repeating, it is diprotic acid, my friend. This is the case. Yes sir, definitely this is the case. Now let us move to the next segment, next question. What is the next question here? That is the question number 2. There is a large difference between the melting and boiling point of oxygen and sulfur. Definitely, yeah. As we know, oxygen has smaller size in comparison to sulfur, and sulfur has a larger size. Clear to you? So, oxygen easily form p-pi bonding. In oxygen, there is a tendency of the formation of p-pi bonding. Due to this reason, oxygen exists in O2 molecule. But due to the large size of sulfur, there is no such p-pi bonding take place. So, sulfur has no p-pi bonding take place, and sulfur exists as acid molecule. Why sulfur exists as acid molecule? Because sulfur has high catenation power than oxygen. That is, the self linking take place very easily. When sulfur link with 7 more sulfur, that is, it has S8 geometry. As I told you, that is puckered ring structure. Do you remember this? This is the case, my friend. This is the structure of sulfur. Now 1, 2, 3, 4, 5, 6, 7, 8, crown shape. Clear? Now, in this case, when more sulfur are attached to it, in this case, it will have high van der Waals force of interaction in comparison to O2. If high van der Waals force of interaction, then definitely it will have high melting and boiling point, my friend. This is the case. Clear? Now, I am going to rub this part. Now, the third question, read the third question, what is given here. Third, that is the answer. SF6 is known. SF6 is known, but SH6 is not known. What is the reason behind it? Yes, as we know, fluorine is high electronegative value. Highly electronegative. So, it easily oxidize, this easily oxidize to sulfur in its higher oxidation state. Again, I am repeating. Fluorine is highly electronegative. Due to this reason, it easily oxidizes sulfur to its higher oxidation state. Yes, sir. Easily oxidized to sulfur to its higher oxidation state, and there is a formation of SF6 take place. Clear? But if I talk about SH6, as we know, hydrogen is very small, but it is very less electronegative. So, it cannot oxidize. It cannot oxidize sulfur to its higher oxidation state, my friend. It cannot oxidize sulfur to its higher oxidation state. Due to this reason, SH6 is not known, my friend. Clear? Now, let us move to the next question, my friend. What is the next question? Listen carefully. The next question is question number 7. Read the question. Sulfur hexafluoride, that is what I am telling, sulfur hexafluoride is used as a gaseous electrical insulator. Yes, SF6 is, my friend, colorless, odorless and non-toxic gas at room temperature, general case. That is, it is thermally stable. It is thermally stable and chemically inert. Clear to you? Due to the high thermal stability and the chemical inertness, that is, it is used as a gaseous electrical insulator. Clear to you? It is used as a gaseous electrical insulator. Clear, my friend? Now, let us move to the next question. What is the next question here? That is the B, that is second question. Draw the structure of SO3 minus. This is very easy question and I think you people can do. Draw the structure of SO3 2 minus. It's very simple. What will happen? That is sulfur. First of all, according to your book, I am drawing the structure. This is the complete resonance hybrid, that is 2 minus. Am I right? But actual structure is, listen carefully. SO3 2 minus, sulfur has 6 electron, 2, 2, 4 and 2, 6. Okay. Now we have O3, that is oxygen and oxygen and oxygen. Put here oxygen. Clear to you? Now minus, put here minus. Now what will happen? It has now 2, 2, 4, 2, 6 and 7, 1 electron requirement. So it will take 1 electron from here. Now this one again 2, 2, 4 and 2, 6, that is, it will require only 1 electron and sulfur will take the 1 electron from them, like this, 1 electron from here and 1 electron from here. Now sulfur has completed its octet like this, that is sulfur. Now here is a lone pair of electron. Now O minus and O minus. Clear? But still, what about this oxygen? It is 6 electron. Now look at what will happen. Still it has lone pair of electron. So it will donate its lone pair to this oxygen atom via partial donation and there is a coordinate bond formation take place, my friend. This is the actual structure of SO3 2 minus. Now this coordinate bond will move here, this coordinate bond can move here. So it has total 3 resonating structure, but in your book it is given like this, that is the double bond here. But this one is not correct, this one is actually correct, complete explanation. So that means to say, that is, it can move here, here and here, like this, oxygen here and oxygen here. This is the case according to your book. That's why I have written this. But if you draw the Lewis dot structure, you will find here. You can also write here the double bond here. That is not an issue. That is, I am showing that it still has a lone pair of electron. That is the showing. You can put like this also. Clear, my friend? So if you have a command over the basic theory, then you can easily solve the question. But what I am telling is strictly follow NCERT book, my friend, because NCERT book is the parameter of your marks in board examination. So follow the NCERT book, what is given in NCERT book. So I am discussing each and everything related to this. Now third one, give a chemical reaction in support of the observation that sulfuric acid has low volatility. As we know, sulfuric acid easily replace the halide, or you can say the fluorine, chlorine, bromine and iodine, and form more volatile acid. That is, it will give you HX plus H2 M2SO4. Clear? This is the case. It proves that, I have discussed during my, it proves that sulfur is less volatile and it forms more volatile. That is, X means, my friend, fluorine, chlorine, nitrate ion also. Clear to you? This is the case. Mx plus 2mx, that is HX, that is M2SO4, and this is, my friend, more volatile acid in comparison to H2SO. For example, HBr, for example, HF, for example, HCl, HNO3, these are the things, my friend. Clear? Yes, sir, definitely. Now I am going to rub this part and will discuss the next question, my friend. What is the next question given here? Listen carefully. Now this is a simple question. I have discussed bond dissociation energy of F2 is less than that of Cl2. Now think on this. You have to do this. Next one, why HF acid is stored in wax coated glass bottle? Why HF acid is stored in wax coated glass bottle? Because we know HF easily react with glass, SiO2, reaction possible. Clear to you? Reaction possible. But if it is wax coated glass, then HF does not react with wax, no reaction. Due to this reason, for the safety process, it is stored in wax coated glass, my friend. Now this question, you think on this. Bond dissociation energy of F2 is less than that of Cl2. I have discussed this thing lots of time. And the next one, discuss the method of preparation of few compound of xenon. As we know, xenon has low ionization energy. If I except radon is a radioactive element, so it has a tendency to form compound. It forms XeOF2, it can form XeO3, it can form XeF2, it can form XeF4. Do you remember this? So what are the method of preparation of few compounds? Now I am giving you few seconds to think on this, then I will discuss. Clear? So I think you have done this, my friend. It's very simple. Now tell me, bond dissociation energy of F2 is less than that of Cl2. As we know, F2, that is a small size. Yes, due to a small size, the non-bonding pair of electron, present in fluorine, that is repel each other. That is due to the inter-electronic repulsion, it will have less bond dissociation energy in comparison to chlorine, my friend. Clear? Now discuss the method of preparation of few compound. Like if I write here Xc plus F2, if the temperature is around 673 Kelvin and 1 bar, what we get? We get XeF2. If we increase the ratio of F2 like 1:5 ratio, then what we get here, around temperature is 873 Kelvin and the pressure is 5 to 6 bar, we get XeF4, my friend. Again, when we increase the ratio of fluorine into 1:20 ratio and the temperature is around 573 Kelvin and the pressure is 2 to 3 bar, what we get? We get, my friend, XeF6. Clear to you? We get XeF6. Now XeF6 on hydrolysis, it gives you XeO3 also. XeF6 on further hydrolysis, it gives XeO2F2 also. There is various method of preparation of a xenon compound, my friend. Clear? Now I have discussed this thing. Now let's move to the next question. What is the next question? Listen carefully. Now wait for a moment, my friend, give me. Now next one is question number 9. What is question number 9 here? Explain the bleaching action of chlorine. It's very simple. When chlorine comes into the contact of moisture, it releases the nascent oxygen. Again I am telling, when chlorine comes into the contact of moisture, it releases the nascent oxygen, and that is, this nascent oxygen shows there is a bleaching action, and it bleaches the colored organic substance to colorless. Color organic substance to colorless, my friend. What I am telling, when it comes into the contact of moisture, it releases the nascent oxygen and it bleaches the organic substance to colorless. This is the bleaching action of chlorine. Now draw the structure of BrF5. What is the first of all hybridization? As we know, BrF5 have hybridization x is equal to 1 by 2, 7 plus 5, okay. X is equal to 1 by 2 into 12, that is x is equal to 6. So we can say the hybridization in this case, wait for a moment my friend. The hybridization in this case, in case of BrF5 is sp3d2. This is the question number 2nd and this is the answer. If I talk about BrF5, the hybridization is, my friend, sp3d2. So it should have octahedral geometry? No. Due to the presence of lone pair of electron, my friend, it has, that is BrF5. Here is F, here is F, 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 and here is F, but here is the lone pair of electron. This is a square pyramidal geometry, my friend. This is the case. Now, which reaction was used by Berthollet to prepare the first noble gas? That is, the first noble gas is XePtF6, my friend. That is Xe plus PtF6 minus, my friend. That is, when Berthollet treated Xe with PtF6, then there is a formation of the first compound XePtF6 take place. This is the which reaction? This is the reaction, my friend. Clear? Now I am going to rub this part and we'll discuss the next question. Wait for a moment. Now, the next question is question number 10. Read the question carefully. Part by part question. That is question number 10. 1. What is given here? Arrange HClO4, HClO3, HClO2 and HClO in decreasing or in decreasing acidic state. Okay. If I write here HClO4, HClO3, then HClO2 and then HClO. What do we observe? In HClO4, chlorine is in +7 oxidation state, here +5 oxidation state, here +3 and here +1 oxidation state. Then what will happen? Higher the oxidation state, higher is the acidic nature. So the acidic nature is HClO4, HClO3, then HClO2 and then HClO4, or in another form HClO, that HClO2, then HClO3 and then HClO4, my friend. Now the next one is increasing oxidizing power, that is the reverse order. The reverse order is HClO4, then HClO3, then HClO2 and HClO, my friend. This is the oxidizing power. Clear? Yes, sir, definitely. Now the next one is xenon does not form fluoride such as XeF3 and XeF6. This is a good question. Xenon does not form. As we know, xenon has all paired electron. Yes. So when the electron jumps from 6p or 6p to 6d, clear to you? Or what is the electronic configuration of xenon is 54. I think in 54 there is the involvement of 5p, not 6. Clear to you? So in xenon, when the electron shift from p to d, that is, there is the involvement of either 2, 4 or 6. So it will form only odd number of it will form only even number of compound, it will react only even number of fluorine, not odd number. Again I am repeating, when there is a, as we know in xenon there is a paired electron, when the electron shift from P and D, P to D, then what will happen, it utilize either 1 3 that the 6, that is the always paired, that is 2 4 6 paired. If there is a 2 4 6 paired, then what will happen, it will only combine with my friend that is even number of fluorine and not odd number of fluorine. Am I right? Yes sir. Now if anyone asks you to draw the structure, the third one is, it's very simple, and I think you can easily solve this. If you have a command over the theory, that is chemical bonding XeF2, we people know XeF2, the hybridization is that is sp3d, but as we know there is a lone pair of electron. If there is a lone pair of electron, then it will have linear shape, my friend. Clear to you? Not trigonal bipyramidal. Yes sir, definitely. Simply if I write here XeF4, you can easily say that is XeF4 has a structure like this because it has hybridization sp3d2, not octahedral, my friend, that is square planar, my friend. This is the case. This all belongs to, my friend, chemical bonding topic. Similarly, if anyone asks you XeF3, that is distorted octahedral. Why distorted octahedral? That is, my friend, X is equal to, has hybridization sp3d2, but due to the presence of lone pair of electron, it has geometry distorted octahedral, not pentagonal bipyramidal. Similarly, you can draw the structure of XeO3, that is pyramidal shape. Similarly, XeO4, XeOF2, completely based on, my friend, Vespar theory, VSEPR, Vespar theory. Now, if you do not know, I am giving you the another technique to how to find the shape. Do not follow the hybridization. XeF2, okay. Now, this central atom, how many electron it has? 8. And monovalent atom 2, that is 10 divided by 2. So we can say number of electron pair, this is the case, is equal to 10 divided by 2, 5. Now how many monovalent atom are added to fluorine, that is added to xenon, that is 2. So number of bond pair is equal to 2. So tell me what is the number of lone pair. The number of lone pair, number of electron pair minus number of bond pair, that is 3. So what is the formula? That is AB2L3. So if AB2L3, by using the chart you will find that it has a linear shape. That is, it has 3 lone pair, my friend. It's very simple. If I write here XeF4, now tell me again, number of electron pair will be, tell me, that is 8 plus 4 divided by 2, that is 6. Yes. Now there is 4 fluorine attached to xenon, that is number of BP bond pair will be 4. Son, what is the number of lone pair? That is 6 minus 4 is equal to 2. What is the formula, my friend? AB4L2, and there is lone pair, 2 lone pair electron, as I told you, so it will have, say, shape square planar. This is the formula to find the shape, and you should have the chart of related to the Vespar theory. Valence shell electron pair repulsion theory you can easily solve. I have discussed maximum number of question, and definitely, my friend, this question will help you a lot. So my friend, time has come, time to say bye bye. Thank you so much.